If you haven't already done so, please print the handout. I'm talking about gas stoichiometry. So this is really very much the same as any stoichiometry problems that we've done before, except now we have added in the idea of gases. So I just want to start with all the formulas that we've learned up to date. We started off by talking about moles. So N is the number of moles, little m represents mass, big M represents molar mass. And we used these values in this formula. So number of moles is equal to mass divided by molar mass. So that was one of our formulas. We next talked about molar concentration in moles per liter and volume in liters. And we used those values in this formula. Concentration is moles divided by volume. Our next concept was molar volume, and molar volume of gases is measured in liters per mole. And the calculation we used was molar volume is equal to the volume divided by the number of moles. The next thing we talked about with gases was pressure, measured in kilopascals, the universal gas constant, which has its own value, 8.3145, and the temperature. And remember, temperature is measured in Kelvin, not degrees Celsius. And we had the combined gas law, which was P1V1 over T1 equals P2V2 over T2. We also had the ideal gas law, which was PV equals nRT. So we have all these different formulas that we can use in our stoichiometry calculations. And for any stoichiometry question, there's some steps you can follow. The first one is always to find the balanced equation for the reaction. Once you have the balanced equation, use the amounts that you are given in the question or that you know from the experiment and convert those amounts, whether it's mass or volume, whatever it is, convert it to moles. Once you have the number of moles, use the molar ratios to solve for the unknown molar amount. And don't forget, use limiting reactant when you have to. And then the new number of moles that you have found will need to be converted into the units required using the appropriate formula, which is all those formulas that we went through at the top of this page. So I'm going to go through a few examples with you. And the first one is, what volume of hydrogen gas at SATP will be produced from 0.100 grams of magnesium reacting with excess hydrochloric acid? So we're going to start with our reaction. This is the reaction of magnesium with hydrochloric acid. So I'm going to add magnesium and hydrochloric acid together. Now, if you look at this, you have to think, okay, what kind of reaction is this going to be, and what will be my products? Well, I have a single element reacting with a compound, so this looks like it's going to be a single displacement reaction. So the magnesium and the hydrogen will switch. So our products are going to be magnesium chloride and hydrogen. So don't forget your rules for finding the formulas. If it's an ionic compound, you have to balance out the charges. So magnesium 2 plus with chloride 1 minus. That means I need 2 chloride ions. So my formula for magnesium chloride is MgCl2. And don't forget also hydrogen. It's one of those diatomic molecules. So it's H2, not just H. And we also need to balance the equation. So we just need a 2 as the coefficient in front of HCl for this one. Okay, now I look through the question and I find out what are the amounts given. Well, I have a mass of magnesium. So I'm going to set up my stoichiometry grid involving mass. I know the mass of magnesium. I can look up its molar mass, and now I can calculate the number of moles of magnesium. Mass divided by molar mass, which gives me 0.00411 moles of magnesium. Now the question is asking me what volume of hydrogen gas. So I need to know how many moles of hydrogen are being produced. So I look at my molar ratio. The coefficient in front of magnesium is 1. The coefficient in front of hydrogen is 1. So that means they react in the same molar amounts. So times 1. It's the same. So I know I have 0.00411 moles of hydrogen gas, but the question's asking me for a volume. So I can look at the question and realize it's talking about SATP. These are standard ambient temperature and pressure. I know the molar volume of a gas at those conditions. So I can use my molar volume formula. And I want to know the volume. So it's equal to the number of moles multiplied by the molar volume at SATP. So the number of moles is 0.00411 moles. And at SATP, you have to look up the molar volume. While at SATP, it's 24.8 liters per mole. So I would just multiply those two values together, and I get 0.102 liters of hydrogen gas. Now I could also change that into milliliters. Sometimes that's easier to think about. It's 102 milliliters. Let's move on to the next example. Second example, what volume of carbon dioxide gas at STP is produced from 50 milliliters of 0.1 mole per liter sulfuric acid added to excess sodium carbonate solution? So we'll start with my reaction. I'm adding sulfuric acid to sodium carbonate. So here I have an acid reacting with a carbonate, and if you'll recall from a previous unit when we talked about acids and bases, you would remember that if an acid reacts with a carbonate, the products are going to be carbon dioxide, water, and then the remaining salt. So in this example, this will be my reaction. And if you take a look, it's already balanced. So now we can get into the stoichiometry. Let's look at the values given. We are given a volume and a concentration. So we're going to set up a stoichiometry grid involving volume and concentration to find number of moles. So I know the concentration and volume of my sulfuric acid. And don't forget to change your volume into liters. N equals C times V. So I have 0.00500 moles of sulfuric acid reacting. And I want to know the volume of carbon dioxide gas, so I need to find out how much carbon dioxide is being produced. It's a 1-to-1 ratio, so the molar amounts are the same. Now, I want to know the volume of carbon dioxide gas. So I could do like I did in the previous example where I take the number of moles, use my molar volume at STP, and calculate the volume that way. But I want to show you another way you can solve a problem like this, and it involves the ideal gas law, which is of course PV equals nRT. Now if we want to solve for volume, we will rearrange it to V equals nRT over P. And then we just plug in our values. So N is the number of moles of CO2, which we calculated up here. R is the universal gas constant, 8.3145. T is the temperature. Well, I'm told it's STP. So at STP, the temperature is 273.15 Kelvin. Remember to use Kelvin. If you kept it at 0 degrees Celsius, you would end up with a volume of 0, which makes no sense. So you have to use Kelvin here. And also, pressure at STP is 101.325 kilopascals. So you want to make sure all your values have the correct units before you plug them in, and then you can calculate. And we get 0.112 liters of CO2 produced, which is the same as 112 milliliters. Before we move on to the next question, I would just want to point something out. In this question, it says excess sodium carbonate. So I didn't need to worry about how much sodium carbonate was being used up in this reaction because I already knew the sulfuric acid was the limiting reactant. That's not always the case though. And I mention that because in this question, I'm not told that there's an excess or limiting reactant. So I will have to figure that out in this question. So it says, what volume of dry hydrogen gas collected by the downward displacement of water is produced at 23 degrees Celsius and 98.3 kilopascals? If 5 grams of zinc is mixed with 100 milliliters of 0.25 moles per liter hydrochloric acid. So you might have to read questions like this a few times in order to understand what's going on, but break it down, start with the reaction. Zinc is mixed with hydrochloric acid. So zinc reacts with hydrochloric acid. It's a single displacement reaction, so we have zinc chloride and hydrogen as our products. And then you balance the equation. Take a look at what information is given. Well, how much zinc? We have 5 grams of zinc, and we're also given a volume and concentration of the HCl. So we're going to set up a stoichiometry grid that involves mass, volume, and concentration, like this. So I can calculate the number of moles of zinc and the number of moles of HCl. So I have 0.0764 moles of zinc reacting with 0.025 moles of HCl. And now I have to figure out what is my limiting reactant. And remember, you can take the number of moles and divide by the coefficient. Do that for both. And compare the two answers. Whichever one is lower tells you the limiting reactant. So in this case, HCl is our limiting reactant. So that's the number of moles I use to figure out the number of moles of hydrogen gas being produced. So I have 0.013 moles of hydrogen gas being produced. But that's not what the question's asking. It's asking for what volume of dry hydrogen gas collected by the downward displacement of water is produced at 23 degrees Celsius and 98.3 kilopascals. So because the question says that the gas is collected by the downward displacement of water, that tells you that this is a question that involves partial pressures. So the total pressure measured is equal to the partial pressure due to the hydrogen plus the partial pressure due to the water vapor that it's being collected over. So remember, we have to look up partial pressure due to water at the specific temperature, and then we can use our total pressure of 98.3 kilopascals and subtract the partial pressure of water, and we'll end up with the pressure of our dry gas, the dry hydrogen gas. So we know the pressure of the dry hydrogen gas is 95.3 kilopascals. I'm asked to calculate the volume, so I'm going to use my ideal gas law. I'm going to rearrange it to solve for volume, and then I'm going to do my math, and you should end up with an answer of 0.34 liters. So why don't you try that, see if you get that answer. If you don't, let me know in an email and I can help you with that.